Morning, everybody. Welcome to the second day of TIFR GS 50 program. So we shall start with 3 presentations, one after the other. The first presentation is by Dr. Indira Chaudhary. She will be followed by Dr. S. Arun Kumar and then Professor Rajashekharan. So there is a slight change. There is an addition in the program. Is talk by Dr. S. Arun Kumar, who will tell us about the history of computer science education on behalf of TIFR. And then we'll move over to the last session where we'll hear the voices of the alumni. So each of the first 3 presentations have about 18 minutes each if we have to stick to the time. And so let's move with the first presentation, and I invite Dr. Indira Chaudhary to come. Our presentation is titled Growing Science in Post-Colonial India, the Historical Context of the TIFR Graduate School.
Which is forward? This one. Okay. Good morning, everybody. It's always a pleasure to be back in TIFR. I spent the years 2004 to 2008 here, 4 years, and set up what you have as your archives today. So that was a privilege and an honor. And what I'm going to speak today is based on what I did at that point, but also some interviews I did later when I found out that I had to present on GS 50 because I had focused more on Bhabha's period. But I'm going to talk about the prehistory a bit today. And I'd like to thank the organizers for inviting me. And I'll just share some of the archival material, but also some of my thoughts that came to me when I was doing this and what I feel how you could use your archives better. So I think what we often forget is the colonial context of science in India. And I think it just needs reminding that science begins in India with these surveys because it was about exploiting the colony. And therefore, no scientific methods were really taught. It was more like Indians helped them gather all this material in the 19th century. But there came a shift, as my supervisor David Arnold has pointed out in the Cambridge history, that by the end of the 19th century, they were very much, there were initiatives coming from Indians. And it's interesting that he points out that chemistry and physics were the 2 fields that the state did not have institutional control over. In fact, medicine was controlled by the state, and so was botany, which was economic botany. They wanted to exploit that. So there, the British always headed it. So I think it is quite interesting that whatever was not used for exploitation was then, Indians begin to work on that. Moving on, I think what Bhabha sort of saw, because he was in IISc, and this is something he's writing in the 50s, and this is in your archives, where he's actually advising Sir James about his visit to IISc in 48. And he says, I think it is more than ever necessary in India today to improve the quality of research and the standard of teaching. Under the able direction of Ghosh, that is J.C. Ghosh, the Indian Institute of Science has expanded enormously in the last few years, and a large number of new departments have been started. But I and other members of the council feel that the level of work leaves much to be desired, and there's too much tendency to concentrate on teaching and not enough research. I will not read the rest out because of the shortage of time, but I think this was a bit of the background of what he wanted to do here. And one of the examples of that research, because I often wondered how, was this true? And when I was interviewing Professor P.K. Maitra for the TIFR archives, I noticed he said the same thing. He said, look at this problem I was given. It didn't even let me think. So I don't think that you should actually give graduate students programs where they cannot think. So he says, I think it only says that the school I came from was not a good school. I feel very sorry to say it, that it didn't help us to do science. And he's talking about Calcutta University in the late 50s. Moving on, I think, in this context, when we look at what Bhabha says in his presidential address to the National Institute of Science in India in 1963, he talks about the tree, how science has to be carefully grown like a tree, and it will take time to grow. And in other places too, he kept saying, this research tradition has to be honed very, very carefully. You cannot really take shortcuts there. And that's why I think all this really forms the background to what he then wanted to do. So let's look at some examples. One example, and he's one of the earliest students, P.C. Vaidya. And I managed to trace him with all the reports that he wrote for the archives in 2008 when I was visiting Hyderabad. And what was interesting is that he remembered all those reports. P.C. Vaidya, of course, had come to TIFR. He was a published author. He had worked with Professor Narlikar, Jayant Narlikar's father, and he was known for the Vaidya matrix. But he was a research student here, and he talked about how there was use of resources that were not available anywhere else. Attended lectures, there were discussions, he had to present at colloquia. There was a lot of peer learning. I learned about the Saturday Club for the first time, where they would discuss papers. And of course, he had to familiarize himself with visiting scientists and their work. So this was very different from what was happening at the universities. Professor Udgaonkar, who you see there, in fact, I had many sessions with him, and what was interesting is that from MSc, when at that point they had to go from institute to institute to listen to lectures and do their lab work in batches, he came to this institute where Bhabha was asking him to read, to keep a log of what they'd been reading, and then sometimes they'd be given problems. And of course, they had to work very, very hard before the stalwarts like Dirac or Pauli came, because many of them then wrote the lecture notes, and that was also seen as part of training. Moving on, this is also something that is going on in the mathematics department, even though maths does not have a program till much later. What is interesting is that there are two very different ways in which this is done, the training, because in physics, what Bhabha seems to adapt out of is Cambridge, which has a tutorial system where you go and meet your supervisor and you discuss whatever readings have been given, to which he's added other things. Whereas what M.S. Narasimhan says, not here but elsewhere in his interview with me, that KC and KGR, that is K. Chandrasekharan and KG Ramanathan, were very aware of what was going on in the US, even though they weren't in the university themselves. They tried to develop, and he says this quite clearly, a taste for mathematical problems. What are the new areas? And he says the resources at TIFR were excellent, because he says, Andre Weil had advised KC to bring the Bourbaki seminars, and everything was here. So I was quite surprised that by the 50s he was reading something that was at the frontiers. And there was training at various levels. So there was the colloquium on function theory. I've just got one of the pictures because I think this is a rather beautiful picture, which is in the old yacht club. And then there was the first summer school with Murray Gell-Mann and R.H. Dalitz. And I think you can see right behind Bhabha is our last speaker in this session, Professor Rajashekharan. This idea of having very advanced courses was followed even by people like Obaid Siddiqui, who joined much later. So this is Maury Fox, Siddiqui, and Marty Gellert at TIFR, and this is the winter school in molecular biology in 67 to 68. From here, Siddiqui and his group go on to talk about how students can be trained in biology generally. And they do have a meeting in Khandala, and I don't have that photographs of that, but they do have the Mahabaleshwar courses, which actually, does interesting things. Because according to Siddiqui, Mahabaleshwar courses are not just about their own students. It's also about building a community outside with people who are teaching in the universities, and as we heard yesterday from Dr. Babu, that it was actually something organized with Dr. John Barnabas of Ahmednagar College. So this was a way in which they tried to build a community where this frontier area could be discussed. And these are some of my very favorite pictures, and of course I've chosen them because there's my friend Veronica and Krishnan, Satyajit Mayer, Professor Jory is here, and Vijay, you're there. So this is also from the interviews I did with Siddiqui. Now this way of growing science, of creating a scientific community, is something that doesn't remain constant, but people keep doing things with it. And here is an interview I did with Spenta Wadia to find out what happened in the 80s. Because when I was here, I did not look at anything beyond the 60s, though we have material in the archives. I was in Bangalore. So I went and had a little interview session with him, and he talked about how he wanted to bring back some reading courses so that people began to read in the frontier areas of science. But what struck me in the interview was something that I think so far we are not talking about, though it's an elephant in the room, that there is a difference between the theory group and those who are doing experiments. And from the beginning, there was a lot of experimental work that was going on. And I think this, this lack of interaction is what he's talking about when he says experimentalists wanted students to work for them on experiments, on fabrication. But over time, the knowledge base of experimentalists went down, and this was a setback. And then, of course, he also talks about learning at various levels. So what I wanted to, say is that this was the way in which science was being taught. But as we did the archives, one of the things that I came across was this quotation, which gave me a lot to hope for. Because I said, maybe Bhabha had something different in mind. And maybe there's still time to think about having history of science in one of these, premier institutions. And of course, the archive remained in its corner. It was not going to really take off and do history of science in any serious way. I knew that Bhabha was serious about this when I heard that there was someone who's passed on now, he's called Vijay Pillai, who came back from Harvard with a PhD in history of science in the 60s and flew back to India where Dr. Bhabha was sitting next to him and said, you know, I must get in touch and we must begin this history of science. It was also something TIFR advised an institution in Sri Lanka to do, philosophy and history of science. And that was done much later. So I have often wondered why this was the case. And this was something that I noticed. I'll tell you a little anecdote and then I'll end. When we found the passports of Dr. Bhabha when setting up the archive, and I was carrying them to the director's office to put them away for safekeeping. Of course, one question was, why were his passports here if he had died in an air crash? And then we figured out at that point in the 40s, 50s, these were all passports that belonged to the 40s. In the 40s and even up to the 60s, actually, you were given a passport every time you traveled abroad. You didn't have a passport which had, you know, multiple visa pages. No, it was quite different. So I wasn't surprised when PhD students stopped me and they asked about this because this was something that needed an explanation. But the next question really shocked me and even made me very, very angry because they said, wasn't Dr. Bhabha a nationalist? Didn't he love India? I said, what is the context of this question? Why are you asking this? And they pointed to the passport and said, why does he have a British passport? I said, do you not know your own history? We were not an independent nation till 47. We do not give passports saying Government of India till 1947. It is the government of Britain. It's the government of UK. And this actually, it just saddened me. I felt, you know, suddenly, why were they doing science in this decontextualized way, where they didn't know where they had come from, what is this place, and, you know, what is its context? And therefore, one of the things that, for all it's worth, I'm going to say that this is a place that can include history of science, philosophy of science in its graduate program, because these same students will do policy later on, and you want them to have a more rounded education, because there is a huge difference between the older scientists I was interviewing and those who I was meeting here for the first time. There was no understanding of what I was doing. There was no understanding of the archive or of history or of its usefulness, which was very different from, let's say, the places I was looking at, whether I saw MIT, Harvard, or Caltech, where the archive is really, really nurtured. And so I have now, I'm ending my presentation with something I wrote and sang to myself every day to survive here, because I felt really there's no understanding of what I do. And this is just a lighthearted look at how scientific institutions might ignore other domains of knowledge. And, but before you listen to this rap, which I wrote up, I want you to know that I'm very, very grateful to TIFR for giving me this opportunity, because setting up an archive of contemporary India was a dream I had had from 1996. And when I did it almost 10 years later, it was really a dream come true. So I'm extremely grateful, and I hope you will take this song for what it is, just a light-hearted song, which is about, no. Can you, loud please. They can't, excuse me? You can't hear, right? Ah, I had set it up. Can you play it from the beginning?
Yo, Rama in the house. Setting up an archive, it ain't no joke. You gotta strive, gotta think of Baba the bloke. You gotta be tough in the TIFR. You'll encounter egos much bigger than their size. So you gotta find yourself a different sort of alliance. You gotta be tough in the TIFR. Or they grab you by the tail and swing you around. Stay focused and land with your feet on the ground. You gotta put up a fight and not take flight. At the end of the tunnel you gotta see the light. At the end of the tunnel you gotta see the light. You'll also make friends who take you for a drink, who'll be there till the end whether you swim or sink. For they know it ain't a joke, they want you to strike. For Baba the bloke, gotta build the archive. You gotta be tough when the going gets rough. You gotta be tough in the TIFR.
Thank you very much. I just want to add that the song was produced by a 20-year-old, and we requested his father, who's actually a music composer, but also an editor of a well-known Bangalore paper, to rap it for us. And I had a lot of fun. I hope you enjoyed that. Thank you.
So thank you, Dr. Indra. So we move on, and I invite Dr. Arun Kumar to make the next presentation.
This. It's okay. Yeah, those aspect ratios. Yeah, good morning, everybody. I'd like to begin with an anecdote. So at the time in 82 to 88, when I was here as a graduate student in computer science. By the way, I'd like to make a little note. The previous speaker missed out on computer science, which is a notable school now in TIFR. But at that time when I was there, it was not a school. The anecdote was that we had a PRO at that time called Mr. Parelkar. In fact, you could make out who the PRO was because he was the only one who was wearing a tie. And at that time, it was possible to request him during lunchtime or other free time to take us on a visit to Professor Bhaba's office, which was preserved at that time. I don't know whether it's preserved now, but and so we went to that office. He very graciously explained a lot of things about the history of the place, about Professor Bhaba's attitudes, values, and so on and so forth. And then we kept opening drawers and so on and so forth. In one of the drawers, I found a notepad. And I opened the notepad, and the first page said, "Arun, I'd like to meet you sometime next week." I asked Mr. Parelkar, "What is this note about? Who is this Arun?" He had no clue. He had absolutely no clue. But there was a sheet of paper in which it said, "Arun, I'd like to meet you next week, AJB." Yeah? Okay, so my name is Arun Kumar, and I'd like to go through some of the neglected history of TIFR. So TIFR originally had just two schools, the School of Mathematics and the School of Physics, and practically everything that was not pure mathematics came under physics. Yeah? And so computing was one of them. So Homi Bhabha had realized long ago the need for computing services and fast, high-speed computing resources, especially for computations in physics. And he got Professor Narasimhan, who had finished his PhD at the University of Illinois Urbana-Champaign. And Professor Narasimhan, under his leadership, the first automatic digital computer in India was built, called the TIFR. Now, since I'm no longer a member of the DAE, I don't have access to the official archives and photographs of the period. So, but in the gallery previously, there used to be photographs of various things, bubble chamber, Professor Bhavar writing something, and the TIFR was also displayed at one place. Yeah. So the interesting thing about this, these were some of the applied. There were other applied aspects in TIFR. One was microwave. Another was essentially digital computing. And a spin-off of this digital computing effort was that the Electronics Corporation of India was established in order to, as a manufacturing arm for the designs produced by TIFR. Later, ECIL became independent. It also produced a clone of the PDP-11, which was again used in a later project by the computing groups in TIFR. Yeah. So one of the first distributed operating systems, called the close-coupled network, was developed in TIFR in the 70s with hardware supplied by ECIL, and they were essentially PDP-11 clones. And the networking for this CCN system was actually under Professor Ramani, with a lot of help from KVS Prasad, Vinod Kumar, and A.G. Joshi at that time. Simultaneously, the software aspects of the CCN was essentially a distributed operating system and a language for programming the distributed operating system called CCN Pascal was developed under Professor Mathai Joseph, assisted by people like Mukul Sinha, Natarajan, and V.R. Prasad, to program this distributed operating system in a high-level programming language. Before that, operating systems were programmed in very low-level languages, the hardware, assembly, and so on and so forth. Yeah. Okay. So what all this led to was the establishment of an organization within TIFR called the National Center for Software Development and Computing Techniques, with the UNDP assisted. It was a UNDP assisted program, and essentially NCSDCT was the nodal center in the country for software development. Yeah. In parallel, there were projects which involved other groups which did computing in various ways. Some were the defense projects of AGIS and ARIN. The AGIS was an Army project, ARIN was an Air Force project, and these were all established under Professor P.V.S. Rao in a parallel group on the same floor. And a lot of the networking and communication expertise that was developed under the ARIN project actually was under Professor Pitke, later spun off this organization called CDOT, which created the first digital telephone exchanges up to 10,000 lines. Before digital exchanges came, there was a probability of about 1 out of 2 that you always got a wrong number. Yeah? And with the digital exchanges, the reliability of telephony itself improved a lot. And the first digital exchange was actually established actually replaced the old electromechanical exchange that used to be in TIFR. Yeah? And in addition, there were, so this group under Professor P.V.S. Rao actually went into other aspects on the border of electrical engineering and computer science, mainly speech processing, signal processing, and such subjects. Yeah, okay, and but all these people were actually employed as, they were essentially people with engineering background, though Professor Mathai Joseph himself had a PhD in physics, but he had moved into essentially the engineering aspects of software. And all these people worked in these projects, and some worked on their PhD too simultaneously. So notably, Professor Ramani got his PhD from IIT Bombay, but he essentially worked here. Mukul Sinha, Natarajan, and V.R. Prasad, who worked under Professor Mathai Joseph, also got their PhD. along with developing the compilers and the operating system for the CCN network. Yeah. There were some PhDs in CS. So CS then began to attract a lot of migratory birds. But even before I arrived, even before we arrived, there were some migrations from physics. So Neelam Soundarajan, who was in the theoretical physics group, moved to computing and essentially got his PhD. Yeah. There were other migrants who came into computer science from the School of Mathematics, who spent a lot of time, then left, and I don't know what they're doing now, so I'm not able to throw more light on them. Yeah. Okay. So NCS-DCT essentially became an all-encompassing software body, encompassing all aspects of software, which includes operating systems, compilers, programming languages, database management systems, networking, then software for Indian languages, graphics for them, and so on and so forth. And this successful implementation of large software products essentially exploiting the power of sound theoretical methodologies, though the theory was a methodology more than actual theory in a mathematical sense. Yeah? But what it did was that it brought in a lot of interest into the theoretical aspects of software development per se. And that's when a small group of theoretical computer scientists actually evolved within TIFR. Yeah. And so most of us actually joined this. The first, as far as I can remember, the first person who got a PhD while working in NCS-DCT was Abha Moitra. She too, I think, had a degree in physics when she came to TIFR, but she moved to computer science. And she was the first formal PhD student of Professor Mathai Joseph. And in any sense, if you were to talk about, so PhDs were granted along the way, but there was no formal program. But the first formal program actually came when this bunch of 5 joined as research scholars. I mean, we were not given titles like visiting scientist or various strange titles used to be there in TIFR, and many people had strange titles, but we were the first formally inducted research scholars. That was the terminology that was used. And there were 5 of us. All of us joined within a few weeks of each other. And Paritosh Pandya is somewhere here. Yeah. And there's this R. Chandrasekhar, which I have grayed out. I mean, the guy was not theoretical enough. He just wasn't theoretical enough. So when NCS-DCT was spun off as the National Center for Software Technology, and later it merged with the CDAC, Chandrasekhar actually moved to NCST and got his PhD from there. Yeah? But the other 4 of us remained here to pursue theoretical computer science. Yeah? And a lot of time, so in a certain sense, there were also other migrants from the speech group and originally from the ADGIS project. Subir Ghosh decided to do theoretical computer science, decided to do his PhD in theoretical computer science. And then in solid state electronics, there were 2 people who joined the theoretical computer science group after something like 3 years. We didn't even know that they were doing theoretical computer science. And that is Venkatesh and Diwan. So ostensibly they had joined for doing some VLSI kind of work or 1 micron, VLSI design and maybe working on 1 micron technology and so on and so forth. But actually, Ajit Diwan was doing complexity theory. And Venkatesh was doing the temporal logic of, he was doing essentially a semantics of certain logical systems, including something called temporal logic. So finally, realization set in, and they moved into theoretical computer science. Yeah. So both Venkatesh and Divan is now in IIT Bombay, is a professor there. Venkatesh is one of the top 2 people in this place called Saskin Technologies. By the way, if the Alumni Association wants more money, the right person to contact is probably G. Venkatesh. He controls a lot of money, yeah? So Venkatesh did his PhD. So Venkatesh and Ajit Diwan also joined the same year that we joined, but we did not mingle at that time. Yeah. So as formally inducted PhD students, even before a graduate program was established in theoretical computer science, we did have formal coursework. So all of us did courses under Professors Mathai Joseph, Shyam Sundar, and Mudur. Of course, Venkatesh and Ajit Diwan did not do this because at that time they were still in Mufti, in solid state electronics. So then we settled down to doing our research with occasional breaks for concerts, films, hacking, which was something that nobody else did in TIFR. We did hacking. We did a lot of programming. And it is after we graduated that the School of Technology and Computer Science was established in 1990. Yeah? But in the process, during the time we spent here, we actually formed a group. It was fashionable at that time. ACM, what is known as the Association for Computing Machinery, is a sort of flagship organization for all computing. They had these special interest groups. So there was a special interest group on programming languages, special interest group on compilers, special interest group on theory of computing, special interest group on database systems, and so on and so forth. We decided to form a special interest group of 4 people on practically everything in computer science. Yeah? And we called it SIGPEX. So what we did was we had this nighttime tea in the East Canteen, and after that we would all come back and one of us would lecture to the others on some material. So all this was done well. Professor Mathai Joseph and Shyam Sundar knew about it, but they sort of let it go because anyway we were doing academic work, right? There were, however, jealous people in other places who used to turn this word around, and instead of calling us SIGPEX, they called us SIGPIGs, right? But that is pure jealousy, I can tell you, because they could not learn theoretical computer science. Yeah. And then, of course, we had a very diverse lifestyle. We attended concerts, jazz, pop, classical, Carnatic. We even organized these concerts here outside the auditorium in the foyer. We had this Amateur Music Association, which was well subscribed by both the faculty and the research scholars of TIFR. We had an excellent film club called Images, for which the bulk of the work was actually done by people in various aspects of computing. I mean, it's amazing. You have this, we created these ballyhoos for each of these films. There were people discussing the jump cut of Godard in the West Canteen, but they had to be educated on what the jump cut was. So we had to prepare these ballyhoos, which we would format on the machine, and we would print it out on an electronic stencil and have it cyclostyled, all with the blessings of the senior faculty of TIFR. Right? And so people would read these 2-page long ballyhoos, basically, which tell you about film techniques, film critique, and film criticism, and so on and so forth. And a lot of people got a lot of education outside of their normal academic routine. Yeah? So we even held some Western classical music recordings in AG 66, something that had probably not been done since Bhabha left. I mean, he himself was a piano player and quite adept at Western classical music. but I think the first recordings I got from Sunil Mukhi, and we used to play them in AG66 with excellent sound system. Mr. Cooper would arrange for it, yeah, and I think what we did was, whether you understood what we did or not, we provided a certain vibrancy in the campus, which I don't know whether it still exists. Yeah. And so I will essentially stop now. But but this is a notable omission from just talking about physics and mathematics, I think, and biology. And I hope I have filled the gap. Thank you.
Professor Rajashekharan, as you all know, is from the first batch of training school.
So good morning to everybody. Let me first thank the organizers, Amit Roy, Vandana and Amol, for giving me this opportunity of indulging in some nostalgia. My TIFR days, that's the title of my talk. After 1 year as a trainee in the first batch of the Atomic Energy Establishment, Trombay, AEET at that time, now called BRC, I joined TIFR in August 1958. Those of us who chose TIFR were taken to visit the experimental laboratories in TIFR. I found that all the laboratories were stacked with huge electronic boxes. Those days, all electronic instruments were using thermionic valves and hence were very huge. I was thoroughly discouraged. I had a dread, a fear of electronics since my bad experience in Madras Christian College. So, although I liked experimental physics, I continued to like it, I had to do theoretical physics. But for theory also I had a problem. Theory needs mathematics, in which I was poor. So, when I went to see K.S. Singhvi, the head of the theory group, I told him that I wanted to do theoretical physics, but I am not sure since I was not good in maths. He said he does not know any mathematics. So, I joined theory. A few trainees who joined theory group in the early years were Sudhanshu Jha, who is here now, and KVL Sarma, who passed away a few years ago, both from the first batch, and Mukunda and Divakaran from the second batch. The atmosphere for study was very good, and there was hardly any restriction on what we can do. There were occasional lectures and seminars which we attended. There was a certain euphoria in the air, and we felt we can do great things. Remember, only 10 years had passed since independence. We felt Nehru was in Delhi and Baba was in Bombay, and all was well with our world. Since my mind was bent on understanding physics at its most fundamental level, I first took up the study of quantum mechanics, since my knowledge of it was not strong. For any question that I asked anybody, the answer invariably was that it is there in quantum mechanics. So I sat with Schiff's book on quantum mechanics for many months and I mastered it, I think. Then I turned to nuclear physics since that was the most fundamental subject at that time. I read Bethe and Morrison and then Blatt and Weisskopf, went to Kailash Kumar and George Abraham for guidance. Kailash Kumar put me in contact with many-body theory, and Abraham put me in contact with few-body problems. Abraham actually even suggested a specific problem. He asked me to redo the deuteron and triton structure using the recently discovered hardcore repulsion between nucleons. I was not satisfied. I realized that the force between the nucleons comes from a deeper layer of reality, which can be understood only from the then new area called particle physics. There was no particle physics research in TIFR at that time. B.M. Udgankar started studying hypernuclei, which was in between nuclear and particle physics. Hypernuclei are nuclei in which one nucleon is replaced by a strange baryon, namely a lambda particle. He introduced me to this subject and also to a few excellent reviews by Enrico Fermi on quantum field theory of radiation, quantum theory of radiation, and isospin symmetry. Udgankar was an excellent teacher. He had taught our batch of trainees reactor physics, and the second batch he taught quantum mechanics. Baba had sent him to France to learn about reactors, but Udgankar shifted to particle physics after returning. Soon, S.N. Biswas and L.K. Pandit joined, and real particle physics started in the theory group. I started reading particle physics and learned that the real theory of particle physics was quantum field theory, QFT. So I finally reached the destination of my inward bound journey. I took up Bethe and Schober's quantum field theory and Yauch-Rolich's theory of photons and electrons. I really loved the systematic treatment of quantum field theory in Benzel's book. I took it during my vacation in my hometown, to my hometown in Kamudy, and read it even during the long train journeys. My learning of quantum field theory was systematized and consolidated only after I listened to L.K. Pandit's course of lectures on quantum field theory. I was so impressed by his excellent lectures that I felt I achieved enlightenment. I still remember lecturing to my friend Sudhanshu Jha on quantum field theory during one of our evening walks along the Marine Drive, describing how I achieved my enlightenment. Maybe he was bored. Soon I began to interact with Biswas and listen to his excellent lectures on integral equations. I was impressed that an integral equation can be easily solved if the kernel is separable. Combining my knowledge of hypernuclei learned from Dalitz's papers with a separable kernel as the potential between lambda and nucleon was an easy job to do. With Biswas's guidance, thus was born my first research paper, and we proved Gell-Mann's global symmetry, which simply equated all the 8 meson-baryon coupling constants, did not work. Dalla Porta visited TIFR and gave a series of lectures on the symmetries of hadrons. This was in 1960, before SU3 came, and he mainly talked about Gell-Mann's global symmetry. Actually, Gell-Mann came to the correct SU3 symmetry in 1961, only after many wrong attempts. Mukunda and myself took notes of Dalla Porta's lectures that came out as a TIFR yellow report. Heitler came and lectured on non-local quantum field theory. Divakaran and myself took notes and brought it out as another TIFR report. Baba had appointed an ex-ICS officer, Mr. Allardyce, as an Englishman, as the deputy director for administration of TIFR. Seminar notices were put on the notice board only after he approved them. Once a notice about a seminar on odd-odd nuclei was sent to him. Odd-odd, even, and even-odd were technical terms in nuclear physics. Allardyce said, these Indians, tanda tanda pani garam garam chai. So saying, he cut off one odd from the odd title and sent it to the notice board. I went on trekking in the Western Ghats with my friends who were senior to me, Chindusona Varke, Bishwarup Banerjee, and K.K. Gupta. Once we were on a hill, and I could see a long thing in a faraway hill moving. Obviously, it was such a huge python, which was visible even from the next mountain. On one such trip, a funny thing happened. It was getting late, and we wanted to take a shortcut. K.K. Gupta suggested that we could cut the distance if you go through a railway tunnel. We were inside, and it was dark. Suddenly, we saw some light in the distance, and we were happy that we were near the end of the tunnel. But the light grew bigger and bigger, and we realized it was an approaching train. We were mortally afraid. It was a very narrow tunnel. There was space only for the railway track. All of us quickly hugged the railway tunnel wall. After the train passed, we thanked our stars and returned home covered with soot and dust. In those days, I used to see many films, sometimes more than one in a single day. English, Hindi, of course, Tamil films in the defense cinema, and even Marathi films. Those were really carefree days. There were two friends and were my constant companions. One was K.G. Nair, a first batch trainee who introduced me to the pleasures of P.G. Woodhouse. The other was V.S. Arunachalam, who later rose very high in the DAE hierarchy. So my life and research would have gone on happily, but that was not to be. One day Biswas told me that I must go to USA for PhD. I did not want to do it. I did not think PhD was necessary for research. Those days PhD was a rarity. In Madras Christian College, Dr. M.A. Tangaraj had great respect because of his doctorate degree, but most faculty members did not possess PhD degree. Also, B.M. Udgankar in TIFR was not a PhD. But Biswas said that it was the policy of the theory group to send young people to for PhD. Biswas suggested that I should go to Maryland University. He liked Maryland University because J.S. Toll, who had written some very good papers on dispersion relations, was there. He got the application form from Maryland. I was about to fill it when he came and said, M.G.K. Menon wanted to see me. I went and saw him. He asked me, why do I want to go to Maryland? I said, I did not want to go, but Biswas asked me to go. He said, I must go to Chicago University. He got the application form from Chicago, and I filled it. Soon, R.H. Dalitz was to visit TIFR, and it was arranged that I must go to Chicago and work with Dalitz. TIFR packed me up and sent me. They bought the tickets, got the passport, visa, everything. Before that, I must describe what I call the Bangalore event. There's a little bit of physics here. In the summer of 1961, the summer school of TIFR was held at the campus of the Indian Institute of Science, Bangalore. Gelman and Dalitz were the lecturers, and the audience consisted of students like me and many stalwarts like Homi Baba, M.G.K. Menon, S.N. Biswas, L.K. Pandit, Virendra Gupta, Yashpal, and Alladi Ramakrishnan. Gelman lectured on his eightfold way version of Sakata's SU3, fresh from the anvil, even before publication. In Gelman's eightfold way, proton, neutron, and lambda were no longer a triplet, but a part of an octet, unlike Sakata model. During one of the lectures, Dalitz caught him. He asked him why was he ignoring the triplet, which was needed to define the SU3 symmetry even. Gelman evaded a direct answer in spite of Dalitz's repeated questioning. If Gelman had answered Dalitz's question, quarks would have been born there in Bangalore instead of having to wait for another 3 years. If any of us had answered the question, that would have been a major Indian discovery. This was surely a missed opportunity. I sailed from Bombay to Liverpool in UK in August 1961 and flew from London to Chicago. The ship journey in SS Caledonia of Anchor Lines took about 2 weeks, stopping at Karachi, Port Sudan, and then at Alexandria in the Suez Canal. We were allowed to land at all the ports and go into the cities. At Port Sudan, a few of us went to see a Hindi movie. On the way, we met a Sudanese and asked him about the way to the theater. He looked at us, asked whether we are Indians. We said yes, and he replied that he will not help us. While the ship was passing through the Suez Canal, we made an inland journey to Cairo and had a sightseeing tour of the pyramids and the famous Cairo Museum. I had planned to write the candidacy examination in Chicago. In Chicago University, the qualifying exam is called candidacy exam. I had planned to write it as soon as I arrived there. So I spent the time in the ship preparing for that. I could revise whatever I knew in physics using the excellent book, the Russian book by Kompanits, which presented all of physics in a capsule form. After 2 years, 61 to 63 in Chicago and 1 year, 63 to 64 in Oxford, I returned to TIFR since I had completed PhD. By 64, TIFR had already shifted to new buildings. Maybe they shifted in 62 in Navy Nagar, this building, Kolaba, from their temporary premises in Old Yard Club near Gateway of India. Baba planned the new building in such a grand scale that it was sometimes called the Taj Mahal of Homi Jahangir Baba. We could work there in peace and comfort. Baba was killed when the plane in which he traveled crashed against Mont Blanc in Switzerland. So an era came to end. M.G.K. Menon took over as director of TIFR. Soon after I returned to TIFR, I started teaching graduate students, although the formal graduate school started only a little later. Many bright students had joined. Among them were Sriram Sastri, Ashok Reina, Deepan Ghosh, Kailash Rustagi, and Vinod Sani from BRC, and many others. Willis Lamb visited TIFR and gave many lectures on the recently discovered Mossbauer effect. Biswarup Banerjee and myself took notes and brought it out as a TIFR report. I went on a trip to the Himalayas with KKG, Varke, Biswarup, and Louis Balash. Balash was a theoretical physicist visiting TIFR. We went to Kathmandu, we flew to Kathmandu, and from there we trekked. Our destination was the Valley of Flowers and Gosain Kund Lake, which was sacred to Lord Vishnu. That was at 14,000 feet. After reaching 13,000 feet or so, we reached the snow line, and we could not climb further since we were not equipped for snow. Further, we were told there were no shelters for the night. On previous nights, we had stayed in the huts of the villagers and finally in a cave. Beyond this point, not even a cave would be there. A Sherpa who accompanied us refused to go further, so we decided to turn back. But one of us, Balash, refused. He said, we cannot turn back without reaching our destination. In fact, he was suffering from diarrhea and could not eat anything. He was the most frail amongst us. Still, he was adamant and wanted to climb further. While we admired his courage and tenacity, we did not want our trip to end in a tragedy. We forced him to return with us. This Balash was a tenacious character. He was well known for his bootstrap calculations, which was part of his matrix theory, and his matrix theory was was the ruling theory at that time over particle physics. Udgankar and Virendra Singh themselves were very much part of it. To begin with, after returning to TIFR, after PhD, I continued my research along lines connected to my PhD thesis. I showed that the hadron lambda 1405 cannot be a 3-quark bound state, but it is a composite of a baryon and meson. Sorry, there will be a little bit of physics now. That it's a composite of baryon and meson, the so-called molecular hadron. I devised a test for it, a very simple test. The test was simply that if it were a quark composite, the K matrix for the meson baryon scattering must have a pole. And such a pole did not exist for the K bar and pi sigma scattering. The experimental data showed no K matrix pole that I managed to show. I talked about this result in a few conferences, but did not publish it in any journal. I got into a controversy with my teacher Dalitz on the work on lambda 1405, since earlier Dalitz, Wong, and myself had worked on this hadron. Dalitz perhaps felt that he should have been a co-author in the K-pole paper. I wrote to him apologizing for what I did and explaining the circumstances in which this happened. Then I wrote a detailed paper making due references to Dalitz and also thanking him. Much later, more recently, after QCD, quantum chromodynamics, came up, it was shown that the QCD also supports the conclusion that lambda 1405 is not a 3-quark bound state, consistent with what I showed long ago. Meanwhile, Gell-Mann's current algebra was making progress, and I worked on current algebra for a while with Pandit and Virendra Gupta. In 1979, the High Energy Physics Conference was held in Kyiv, Russia. It was I was one of the delegates chosen by TIFR. They got the visa and bought the ticket. They brought them to me along with a form to be signed by me. Jalihal, who was the administrative assistant, brought it to me. I was supposed to sign a bond to work in TIFR for a certain number of years because TIFR was financing my trip. I refused to sign. I told Udgankar, who was the chairman of the theory group, that under the circumstances I would not go to the conference. They said it was a mere formality, but I said I was against signing any bond on principle. They wanted to consult the director, Menon. He was out of town, but on return, instead of coming to TIFR, he stayed in the Tata house. So I did not go to Russia. Looking back, the whole thing appears to be a silly thing done by me, since I did not have any intention of leaving TIFR. And so the bond was really only a formality. I have described this event only because this is the only time I fought with TIFR. Because of this fight, TIFR removed the requirement of the bond subsequently. Maybe as a consequence of this fight, I undertook a pilgrimage. I visited Kanchipuram, Tiruvannamalai, Srirangam, Kumbakonam, Chidambaram, Madurai, Srivilliputturu, Thiruvananthapuram, and Susindram. This was the first time I visited so many places except Madurai, of course, which was familiar to me. I was truly amazed at the cultural magnificence of Tamil Nadu. Although I have mentioned some physics, I might have given the impression that most of the time I was playing around. To show that that is not the case, I will now describe some of my physics activities very briefly. I became aware of Yang-Mills theory by reading Sakurai's paper in the Annals of Physics in 1959 while I was in TIFR here. That was the first paper in which Yang-Mills fields were used in particle physics. Sakurai constructed a gauge theory of strong interactions. I continued to be interested in Yang-Mills theory from that time. Beltman's lectures at Varana Summer School, which I attended, where he talked about the conserved weak current, impressed me very much, and I felt that weak interaction must be described by Yang-Mills theory. So when Weinberg's paper on the SU2 cross U1 electroweak theory came out in 1967, I had no doubt that that was the correct theory. I read the papers of Goldstone, Higgs, and Kibble. In the subsequent 2 or 3 years, I lectured on these at various places, including TIFR. In particular, in June 71, I gave a series of lectures on the gauge theory of weak interactions, including Yang-Mills theory, Fadi-Popo-Gauss, Higgs mechanism, electroweak theory, Jim mechanism, etc. It came out as a Saga Institute report. This was the first connected account of what later became known as the standard model of high energy physics anywhere in the world, as far as I know. It even contained my conjecture that the massless Yang-Mills gauge quanta cannot exist as a particle because of the incurable infrared divergences. This was an early suggestion of what became known later as infrared slavery and color confinement in QCD. Nevertheless, I must admit, I failed to make any substantial contribution to gauge theory. This was partly because I had to take care of my sick father at that time. I tried to get him treated in Bombay as well as in Madras, but to no avail. He passed away in May 73. I became aware of Toot's proof of the renormalizability of the electroweak theory, which came out after my Saga Institute lectures. Then came the discovery of asymptotic freedom of Yang-Mills theory by Gross, Wilczek, and Politzer, and the construction of SU3 color gauge theory by Gell-Mann, Fritz, and Leitweiler to describe strong interactions, known as QCD. Renormalizability of Yang-Mills theory with spontaneous breakdown of symmetry and asymptotic freedom of Yang-Mills theory are the two most important discoveries in quantum field theory after the discovery of renormalizability of quantum electrodynamics in 1947 by Feynman, Dyson, Schwinger, and Tomonaga. I missed the boat in both. Although I was well placed with potential to contribute, I had already studied path integrals, which to use it in his proof, and was already giving lectures on Wilson's renormalization group and Galant-Riemann equations, which are the ingredients in the discovery of asymptotic freedom by Pulitzer, Gross, and Wilczek. Although I missed the stage, I was sitting in the front row. I could catch their significance as soon as the discoveries came tumbling one after another. The years 71 to 73 were truly exciting years. It was the watershed in the development of high energy physics. Actually, until Tooth's proof, perhaps nobody except Joe Schechter of Syracuse University, who added a U1 current, U1 to cancel the strangeness changing neutral current, and myself had taken Weinberg's theory seriously. Even after Tooth, only a few theoretical physicists took it seriously. A situation changed dramatically after the discovery of the weak neutral current interaction in the CERN experiment by Perkins and others in 73. Weak neutral current interaction is almost as strong as the usual charged current weak interactions that lay undiscovered all these years, 40, 50 years. It could have been discovered many years earlier if only the experimenters did not listen to some theorists who said neutral current cannot exist. The theorists thought that neutral current would lead to strangeness changing neutral current decays, which were not seen, but they forgot that there could be strangeness non-changing neutral current. So the experimenters ignored some data which were actually due to neutral current. But the clinching experimental proof was possible only after the huge Gargamel bubble chamber was constructed at CERN. Because of its size, they could clearly distinguish a pion from muon, and this was crucial for the discovery of neutral current interaction through the absence of muon in neutrino collision. As soon as the discovery of neutral current was announced, Kaviel Sharma and myself produced the first model-independent analysis of deep analysis data and tried to extract the coupling constants. Sakurai called our equations the master equations. His analysis using our master equations and his analysis of elastic scattering and coupled with Lalit Sehgal, Lalit who was here a little earlier, Lalit Sehgal, of single pion production led to the complete determination of neutral current coupling constants. There is the possibility of quarks having integral charges unlike the Gell-Mann-Zweig quarks, which were fractionally charged. The integrally charged quarks were introduced by Hahn and Nambu. Prabir Roy and myself here constructed a color gauge theory based on Hahn-Nambu quarks, and we got two interesting results. One, although Hahn-Nambu quarks have integral charges, we showed that as observed in deep inelastic scattering, they will appear as fractionally charged. Second, in this theory, the gluons are electrically charged. We published this in Pramana, and soon we saw a preprint by Pati and Abdus Salam, who also had the same theory, but they missed the fact that gluons in this theory are charged and hence contribute to deep inelastic scattering. We pointed this out to them. Immediately, Salam sent us a cable saying that they were wrong and we were right. Also, they corrected their paper. Unfortunately, subsequently, after I shifted to Madras with my students and collaborators, Jayaraman, Lakshmi Bala, and Saurabh Brindani, I tested this theory by comparing the results with experimental data, and the theory agreed with data and could not be ruled out. To this day, this theory of Hahn-Nambu quarks has not been ruled out by experiment and may even turn out to be the right theory. Color is broken in this theory spontaneously. One morning, my wife was looking at Times of India in the morning and exclaimed, "Look, your friend Kaviel Sharma's name is in the front page." I looked and found she missed my name. The news item in the front page said that Rajshekharan and Kaviel Sharma have discovered a new particle. Sometime earlier, the Kolar experimenters in TIFR had discovered some events that could not be explained on the basis of known physics. Kaviel and myself interpreted them as due to a new particle. I also described this in a brief article in Physics News. Times of India picked this popular science article and wrote their story. There was no mention of the experimenters that included M.G.K. Menon. I was flabbergasted. I contacted Times of India and asked them to withdraw the story or at least publish a correction. They refused and said I could send a letter to the editor. Times of India could have verified the authenticity of their story by simply phoning TIFR. They did not do it. That is the level of science journalism. Anyway. Recently at IMSC, MVN Murthy and myself have interpreted the 40-year-old Kolar events as due to dark matter particles. I visited USA in 1974. Sandeep Pakwasa had invited me, and I traveled with my whole family, and we were working with, for 2 months I worked with Sandeep. But in October 74, an earth-shaking news came. That came to be known later as the psi particle discovery. At that time, we only knew that some extraordinarily narrow peaks had been seen in electron-positron collisions. It was as if anthropologists stumbled upon a group of humans in some remote corner of the world.
Mr. Rajashekharan, can you conclude?
Yeah, in 2 more minutes. In some remote corner of the world, human beings lived for 100,000 years. That discovery was like this. After that, there was no peace. San 51 was constantly at the phone trying to get more information about it, and we wrote a paper having our interpretations, a dozen interpretations we could give for this phenomenon. Fortunately, it included the correct interpretation, which we know to be a bound state of quark and a charmed quark and an anti-charmed quark. After Hawaii, I took the family on a tour of mainland USA, visiting many places and giving seminars there. So everything was going very well at Bombay, so why did I decide to leave Bombay? There are several reasons. For some time, anti-South Indian feelings were gaining ground here in Bombay. When there was water shortage, they even wanted to send back all the Madrasis. One day there was a big agitation in the streets. When I was waiting at the Gymkhana for the TIFR bus, some goons got hold of one of our TIFR colleagues and beat him up. So I decided that when a chance came, I must leave Bombay. Second reason was that my children hardly knew Tamil, and my wife spoke only Tamil. So I felt that my children must grow up in an atmosphere in Tamil Nadu where Tamil could be the language. A third reason was that I felt I must use my knowledge to teach at a university. Those were the days when Indira Gandhi introduced the slogan, "Science for the People." Udgankar was advising everybody that TIFR people should go to the universities to teach. But none of this is a strong enough reason. So I must attribute my shifting to Madras in '76 to fate. My years in TIFR 58 to '76 were truly wonderful years. Thank you for your patience.
So for the next session, I must hand over the baton to Inakshi. So before she arrives here, let me share with you two very small things. Some of us have a doubt as to the purpose for which TIFR was created. So there is this book on papers, collected papers of Homi Bhabha, which was brought out during the centenary year. It used to lie in the TIFR library, and I had read them as a graduate student. So in this, there is a paper which is 2.5-page paper titled Allocation of Scientific Research to the Universities. This is 1944. It predates Bhabha's letter to Saklatwala, and it clearly states why TIFR was needed as a separate research institute but attached to a university. Today we are a deemed university, so this 2.5-page paper should clear everybody's doubt, the purpose for which the TIFR was created. So that remains as strong today as it was in 1944. The second is the very special status of TIFR vis-a-vis the atomic energy system. So as all of you know, that for the first 8 years, the money for TIFR as well as the atomic energy came through Department of Scientific and Industrial Research. So namely, it passed through Shanti Swarup Bhatnagar. So Bhatnagar himself stated at the time of inauguration, at the time of laying the foundation stone of these buildings in 1954, that Council of CSR had decided at one time officially that the CSR will never build a national laboratory for fundamental sciences. And Bhabha's TIFR was to fulfill that role. Then there are these notes which Bhabha sent to Nehru on the eve of inauguration of TIFR buildings in 1962. So in those notes during the centenary year, I found this something which is again recorded by Homi Bhabha, that in the 27th meeting of the Atomic Energy Commission on April 23 and 24 in 1953, Bhatnagar took the initiative as a member of the Atomic Energy Commission that the Department of Atomic Energy, which was yet to be formed, it came up only in 1954, but Atomic Energy Commission had been there since 48, that the Atomic Energy Commission will not build any any institution or laboratory for fundamental studies or fundamental research and mathematics. So Bhabha's TIFR was to fulfill that role for the nation, and that is why the byline started to appear later on, that we are a national center for nuclear science and mathematics. And nuclear science was not physics, but nuclear science included anything which has an atomic and molecular basis. So everything else which was not pure mathematics was classified as a nuclear science. So I think the students of TIFR must read this, just 2.5 pages paper of 1944. It predates the Bhabha's letter to Saklatwala, and that what is the special role of TIFR on behalf of atomic energy, on behalf of the nation, and as something which is connected to the university, but it has to be outside the university system, because the tasks that were assigned to TIFR, they cannot be carried out in the universities. The consortium of universities cannot perform the role assigned to TIFR. And unless we take away that role from India as a nation, the purpose of TIFR as a national institution ought to exist. Thank you very much.
Good morning. I'm Inakshi Bhattacharya. I joined the Solid State Electronics Group in 1980 with Professor Shubhendu Guha first, and later continued with K.L. Narasimhan, and I left in 86 February. So this, mic is not on? Oh, closer. Thank you. So this session is reminiscences, loosely, anyone can come up and talk. It's for about an hour. So I request people to come up, and please don't take more than 7 or 8 minutes. And if people don't volunteer, I'll call out. Let me start with Sanjay. Come. Sanjay Jain. Come on, you have been marked. Quick. Yeah, just but face the people.
I joined TIFR in 1981 in the theory group, and finished my PhD in 1987 and left. I'm right now working in the Department of Physics and Astrophysics, University of Delhi. There are several memories associated with TIFR. Of course, TIFR made a profound contribution to my education and my personality in multiple dimensions. And there is no question about the fact that much of what I have done and am has been sort of foundationally made in TIFR. So let me, I'm not prepared for this, so I'm just extemporizing. There was no graduate school when I joined. There was no formal graduate school. There were no regular courses which were happening. And after a year or so, there were some informal courses which we were supposed to take. And so those courses were, there was, it was not, one didn't have to pass those courses or anything like that. One took them and one understood them. And I think some amount of formal stuff, if there had been some formal coursework, it would have been quite helpful. What happened was that my mentor, who, when I joined, I was supposed to have a mentor, Professor L.K. Pandit. He asked me to read quantum mechanics from Dirac's book. And so in the first year of my stay here, I read 4 chapters of Dirac's book. And that was all that I had to show at the end of first year. The pace of things was such that I was working at my own, I was reading things on my own, discussing with people, occasionally students and so on. And I really enjoyed that period where every line of Dirac's book is something that I was trying to understand clearly and making my own notes in pencil on Dirac's on book. And while that was not much to show, at the end of, we were supposed to write our reports at the end of the first year. Every year we were supposed to write reports, what you've done. So I was writing that I've read 4 chapters of Dirac. It felt very sheepish. But actually, that was, looking back at it, while I didn't, make a lot of progress in terms of volume of material, there was a kind of, sort of cultural and sort of ingraining a sense of understanding the depth of every statement made by Dirac and the meaning of all that. So there was a certain kind of culture that was imbibed. And so this is one aspect of the kind of pace and the kind of relaxed atmosphere in which, perhaps this was too relaxed, but this kind of pace and sense of a time and sort of space to contemplate and think about things is becoming completely a thing of the past. We don't have that anymore. Then at some point, Spenta Wadia joined the theory group, and I started working with him, and there was a complete change of pace. And so I finished my PhD with Spenta Wadia, although Professor L.K. Pandit remained my mentor all throughout this period, and I was fortunate to have both of them mentoring me. With Spenta, I really learned here just very concretely how to do science, how to get into the frontier of research, the taste for problems, what kind of questions to address. And it was a very, Spenta was a tough taskmaster, but it was very inspiring to work with him and do science. One of the most important things that I remember here is that in that period, we started what was called the Group for Nuclear Disarmament. And that was actually started by efforts from people, from scientists in TIFR. Biswarup Banerjee was one of the persons who was very much involved, and later on Spenta too. And there were people from the city of Bombay, artists, journalists, people from filmmakers, people from various walks of life, that joined in. And that was a kind of an education which I had simply not bargained for. And it was very intense for the period that it lasted. And it again had a very deep influence on my personality in terms of making me aware of society at large and concerns and what are the things that we need to engage with. Our political stance at that point, in retrospect, and we realized it soon after, was very naive. But the fact was it sensitized us, many people in TIFR, students, faculty, to issues beyond our immediate scientific life. So I think that this, I've probably already taken too long, but TIFR really contributed in a multidimensional way to my growth and perhaps to the growth of many other people.
Thank you, Sundar.
Good morning. It's good. You want to introduce me. I'm Ranga. I belong to the very first batch. I got my PhD under Professor Jha. And we, the vibrant campus and things like that, what you talked about, is something where we had contributed quite a bit during our days. We are the first occupants of the E1 block. Now it's called differently, I think. And I was also one of the first few to sort of break away from the regular tradition of continuing to work in physics. And I decided, on almost like a sudden decision, we had the Wednesday colloquium, and one of them was by the chairman, managing director of ONGC who had come, and he was talking to all of us. And after we used to go for the Wednesday colloquium more for the chips and whatever things you'll get out of the cashew nuts. So we attended it, and we were listening to that, and then we walked into the West Canteen, and we shared that table with Mr. Prasad, with the CMD, and we were just chatting. You were saying, look, we don't get such brilliant people like you. You are the cream of youth, but you're all sort of here in such isolated places, but we want people like you and all that. Just telling more for just yet to continue the conversation. But we took it very seriously. You mean to say that some of us can really come and work in YNGC? And he said, yes. There were 5 of us. We went back to Jha. Professor Jha was shocked to see that why are you guys wanting to go to YNGC? Because Dehradun, we have never been there, and YNGC, we have not heard about any of those things. We decided, okay, we have to go there. The industry part, which was talked about yesterday, we were one of the first to go to industry. And the people who went, one other person who went with me is unfortunately not with us, Chandrasekhar Jain, a very, very nice guy. And Dilip Kale wanted to come here because of some personal reasons he couldn't make it. And we all went there, and we did not take that approach. Yesterday somebody was saying, go to the industry and you just think, Ramu Ganguly was mentioning, about, we are all very brilliant and these guys don't know anything. We are the opposite. We felt, what is this? These people talk about Bombay High. What is Bombay? We know Bombay High and all, we don't know. And what is this process? I mean, many, many of those things. Anybody who talk to you, they will say, oh, we have been in geology, geophysics for 15 years. You guys come to today, and how do you expect to be a part of our organization? But then the TIFR culture, which has got into us, we never give up. We are starters. We decided, okay, look, there may be some new things. Why not we learn? We have a group of 5. Nobody else will even come and mingle with us. Lo and behold, after 3 months, the 5 of us conducted a training course for the geologists, geophysicists. We're all very senior guys. They listened from us. We gave so many ideas. My first paper was with one of those geologists, N.D.J. Rao, which got the best paper award in geophysics. We published it because it's something which we know that the kind of things that we have learned here, the analytic capabilities can be taken elsewhere. So we always believed in that the TIFR with a government-funded institution of this high quality, at least some part of it, how do you get it out to other industries, other organizations? So we set that trend to some extent. But then I decided at some point of time that I will go ahead and move on to ISRO, because just like Homi Bhabha, Vikram Sarabhai's vision also was something very catchy. He was talking about applications should drive the entire program. which is what I always have thought. Technology for its own sake is never great. You can produce a nice cell phone with 25 MP, 100 MP camera. Just because supply is available is not what I want. I want it for some purpose, and if as long as the demand is met, I'm happy. So therefore, I thought this space thing attracted me. You all met with me one of those days, and then I moved on to ISRO and continued with an extremely good career in ISRO, but all the time, because of the very, very strong foundations I got here for 6 years, were extremely good, and the connections that you used to have with people here are lifelong. I will just give you one anecdote of that type. Basically, Karamjit Arya was my, we worked together day in, day out, same grade. Arya and I were very, very thick, and in fact, I visited them with my daughter and his daughter and all that. Suddenly, we have not talked about Arya in my house and all that. We go there, and as though we have been daily talking, we just continue to discuss there. Both our daughters were amazed. What is this? You guys never email each other, never greet for your birthdays and all that. And how do you? They said, no, this is exactly this. Arya, Ranga, we always mingle like that. Now he unfortunately passed away. His daughter, Ranjita, she attended some symposium somewhere in the New York, which is 200 miles from where I was living. She comes all the way, comes to my house. She said, DC, a lot of people come through, show the museums and all that. She said, Ranga uncle, I'm not come here to go and visit any of those places. Next 2 days, I'm going to stay with you, because my dad has told me, you and my dad are one and the same. So you are my dad now, I want to stay with you. It's amazing kind of this thing which has happened everywhere. I meet him after some 30 years. It's exactly like what we were doing in the TIFR campus. That kind of a closeness is what TIFR could build it. I will end with some important comments, because yesterday's Amit's session was something where you had a panel discussion on the floor, on the dais, as well as outside, so we could not give some very important comments. I want to add on 2 important things. This outreach part of it, because there's a very, very important thing that science today requires to be taught differently. The books and all that, whatever, the teacher training and all that is very limited, and students no longer require the teachers for giving knowledge. They should be mentors, because the giving knowledge, they can get it from Googling, whatever phones that they have. So what is more important is to understand experiments. They said that, how do you conduct experiments and all that. Now, in fact, I'm associated with one school, which is an elementary school, which is sort of in an absolute rural area close to my house. I go and spend time, there's something so unique. And the teachers there, and when you try to talk to them and all that, it's possible that all those kids who are all coming from absolutely poor background, first-time schoolers, the parents haven't been to school, I am able to transform them, because it's personally, how do you get this concept across, how do you make them understand angular momentum conservation. So easy when we can do this. But then I was thinking, it's very, very important that we should spend time in terms of getting that kind of a training. For example, one of the things when I was in the 80s used to love a TV show was when Professor Eshpal used to come and talk about something on science. I don't remember what is it called, I don't even remember. But people used to get glued and look at those things. What is it called? Turning point. Turning point. But now look at how many different channels. Those days it was only Doordarshan, so a few of those shows. Today with so many channels, you keep on looking around, there's not even 1 or 2 watchable programs on this. And if you make it interesting enough, if each one of them, Rajaji creates one such thing, I'm sure people will want to watch, because there cannot be better persons to get these messages across than the people who have been in TIFR, very senior people. You get hold of whichever channel sponsors you, and then you make it such interesting programs. So it will not be only the students, the parents, all of them will watch. They will start understanding the concepts much better. It's even better than creating. I was first thinking, okay, why not we create a mobile exhibition, take it to different places and then explain. But those reaches are very limited. Whereas through the media, I think getting this and asking our people to conduct such shows and create another turning points will be something very much doable. Let us do it. I am very much willing to participate in any of those things. In fact, I am doing it for the space camps. I go for the, because similarly for the, ISRO also wants all these outreach, they call it by some such name. What happens is I've been going to different places and then talking to the students there, and then getting them more and more interested in this. And then, of course, Chandrayaan 2 gave so much of exposure. But then that is only one type of event, but we should have regular events, and let's all do that. And I'm very much part of that. Very, very happy that you gave me this opportunity to be part of this get-together. Bye.
Thank you so much. Volunteers? Yeah, do I have any volunteers? Suresh, come. Let him come.
I am Suresh Sandwankar from Solid State Electronics Group. I joined TIFR in 1976 and retired in 2012. Very long, 36 years of work. Today morning I was standing at, am I audible enough? At the TIFR bus stop near VT, and I was reading this book. What a wonderful book produced. And one of the old colleague was standing nearby and he was asking me, what is your concern with this? We know you for your work with the staff welfare and union of the TIFR and Rajmachi Rural Aid and Development Program and so many other things, running the music library, playing records in the lunchtime and helping images and what are you doing here? So I told him that as I was doing all that, with the persuasion of Dr. B.M. Arora and Subramanian and many colleagues, I also dabbled a little bit in this. So I did my PhD in 2004, took 10 long years because I was working as a scientific assistant in the laboratory, and I was given a permission, a liberal permission that I can do a course, one course in 6 months or so something. But I was asked also to go through all the formal procedures like qualifying interviews and attending graduate schools and then doing further work. So I am really indebted to all my teachers. Professor Jha is sitting here. I took his course. Professor Narlikar, although I did not take it for credit, but I attended the course because this graduate school really taught me how to stand up and talk to people, how to present your work, how to write project reports, and how to submit final reports. For last 6 years, I am working on my old passion of collecting old gramophone records and spreading the old recordings all over the world through all social media. And for last 6 years, I'm attending conferences of all kinds in the archiving and documentation of music in Europe, US, Asia, everywhere. And really, I'm here standing to pay my respect and gratitude that this graduate school and the rigorous training in all kind of courses and this training which goes in making you a PhD or your career, that really has helped me, and that's why I'm very much thankful. And indeed, it's a really wonderful reunion. Thank you.
Thank you, Suresh. Come, Mani. I was just going to call you if you didn't volunteer.
Thank you, Inakshi. My name is Subramanian. People call me fondly Mani because everybody likes money. I remember even some poems have been written, money, money, sunshine, blah, 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 all those things. Anyway, I joined TIFR in 1972. That is Arun, Grover, Neelam, Soundarajan. Ours was a moderately big batch, I should say. I joined Solid State Electronics Group, Dr. Guha and Professor Arora too. Did my PhD here, of course. I was here until 1992. Before that, of course, I had already gone one postdoc and returned back to, but this time when I went in 93, I went to Oregon State University. Afterwards, I did not return, I should say, because there was an opportunity for me. They inducted me into the faculty. But I wanted to share a little bit of my journey in this so that it may be useful for the students here about the collaborative work and interdisciplinary work, how you go about it. A lot was said yesterday about those things. When I went there, I wanted to write some proposal. There was this nuclear engineering department there, and there was a nuclear reactor. Many people didn't even know that there was a nuclear reactor right on that campus, and it was one of the very few universities that had their own nuclear reactor on campus. So my area of is solid-state electronics, solid-state devices, and it occurred to me, why not we study the radiation hardness of special devices, my area of gallium arsenide and all those heterojunction devices, and that is very kind of new. All the space-based electronics, about this. Silicon devices, very well known, but this field was very, very young. So I wrote a proposal that you go and talk to the nuclear engineering department. Collaboration is so easy over there. And they liked the idea, and then it started off like this. So there's, the idea of this is about, yesterday it was mentioned that there should be no barriers. You should just be able to go and talk to this. But this skill, I should say, I had already developed at TIFR here. There was a lot talked about all this theory, experiment, blah, blah, blah. I never had, this feel that I was doing a lowly part of science, because I do it because I like doing it, and this is where my passion is. However, I wanted to find, there were a lot of theoretical work going in this area too. So I used to talk to Mustansir Barma, I had talked to Deepak Dar, and highlighting some of the problems which are going on in this area. And they helped me too. And so that the idea here is that the initiative should come from you. You should, whenever there is an opportunity, you should take it there, and people will be helped. We should not, I think we should create an atmosphere where there is no barrier. People doing theory, they should be willing to help experimentalists, interact with them, and similarly the experimentalists should feel free to go to them. And so you can think of it as, in my journey, even though I did physics there, I was a faculty in electrical engineering department because this subject was all taught in electrical engineering. So it gives me a very balanced view of idealistic physics versus all the practical engineers, how they go about it. In fact, all my PhD students at Oregon State were physics students. And all the EE students, they never wanted to go beyond masters because that's where a lot of money is. And it took me a long time to understand why these guys don't want to go to PhD, where physicists, they always wanted to PhD. It's a little bit of a joke about it. In physics, you always have only the PhD program, but however, you do your coursework and all this kind of exam, and those who don't make it, they get their master's degree, like the consolation. That's why it was considered low. Whereas engineers are smart; they just want to go and make money and progress into it. So the idea is here, there is no such thing as physics, engineering, and later I moved to industry too. I worked at HP for a number of years in the same town, while simultaneously maintaining my position at the university. So this journey has taught me to break the barriers and work freely across the borders. And I think it has been a very fruitful experience for me. Okay. With this, I will hand over the mic. Thank you.
Thank you, Mani. But I think these barriers are not there. I remember Mustan Seth, Deepak walking down to our lab. They were building some model for percolation theory with Arora ji. That was so, we just have to go. And in fact, I'll add my story to it. I did solid-state electronics here. My first job was in physics in IIT Kanpur. Then I moved to electrical engineering and have been there in IIT Madras for the last so many years. And I work on MEMS, microelectromechanical systems, which is bio and biosensors, and so mechanical engineering. So it's all very interdisciplinary. And I keep telling my students that you must have an open mind. So who's the next volunteer? There, please.
Okay. Maybe I thought whether I should say a few words or not. I was debating because I have been still here. All right. So I thought I want to touch upon a few points. So my name is Lokesh Trivedi. I am in Department of Nuclear and Atomic Physics for many, many years here. And I started my journey here. So of course, TIFR formally structured graduate school that time. So 1987, when we joined here as a graduate school, that time graduate school really well formulated and very strict structure, and which continues some form or the other now, which is even well structured now. So yesterday there are a lot of discussions, so I thought few points I want to touch upon. One thing is experiment versus theory. So yes, there was 20, 25 years back, scenarios was different. I mean, there was no experimental physics in the first course, but TIFR always makes progress, makes changes every year, maybe every day. So one thing is that in the coursework nowadays, we have also last 20 years is now, we have a very well structured experimental physics course, which is to be taken by everybody, including theorists. So they really go through whole semester, in the whole year, courses, and every lab they come, and one experiment they do for 1 month. So they have hands-on experience. So this is corrected. I think there are a lot of discussions yesterday. So this is corrected, I think, which is a very good thing. Of course, whether theory versus experiment, that's a personal perception that we cannot touch upon much about those things. But one thing why you wanted to mention here, that's the reason which I picked up this mic, that previous to TIFR graduate school, we have a prehistory. We come from MSc, which is also TIFR joint MSc program with Pune University. So I come from that batch. In fact, I was the first batch. I think that's a very wonderful experience we had. So we already had a major graduate school before we come to graduate school. So we had very, very interesting and good teachers like Professor Nalikar sitting here, and Professor Udgaonkar, who was very much articulate in that coursework, and many other teachers. Of course, our next batch was Rana, Professor Rana, and of course Antia. He used to come to Pune University, so many of them, and there was a huge and very nice course. And this was supported by then, of course, the director who passed away a few days back, Professor Srikantan. So I remember those things, so I thought I should mention a few things that TIFR has been always trying to engage with the universities, some form or the other, which nowadays, of course, many other places have come up, like CBS, or even other places where university is doing like a BSc level or MSc level courses. So it's a wonderful experience, because when we came to TIFR Pune University joint MSc program, when we found the first time the experiments work. Before that, during BSc days, we used to do experiments, whether it works or not. Of course, everybody passes through their courses, but that gives a really confidence that you can do experiments and it works. And when we came to TIFR, that gives a really an encouragement to join experimental physics. So we joined, many of us, our colleagues are here, of my same batchmates here, and we joined experimental physics, and Pelletron was that time was just coming up. And after our immediate 1.5 year very strong graduate school, actually we could take up building of instrumentations. Like Pelletron, whatever you are seeing that, some of us, we built our old experimental chambers, and first time in the first beam time cycle. 1989 we had the experiments, and that journey till continues. So now, of course, many of us have the responsibility of giving the beam times to others, not only taking your own beam times, but we have to see how, and that gives us another encouragement that which we could build a new accelerator. Like right now I have a ECR ion accelerator in the laboratory. So that gives you a courage. So encouragement in the TIFR, graduate school, instrumentation, experimental techniques, and so on. And that gives a real boost to the whole system. Anyway, I would like to acknowledge, of course, that time I had in condensed matter physics initially. I did my projects, which is none other than Grover, who is present here. He was the boss that time mine. Yeah, sure. And our graduate school teachers are Professor Jha and again Professor Nalikar, Mustansir. So we had a wonderful graduate school. So I think this graduate school that way has a lot of positive things. At the time of graduate school, we ask this question ourselves, why do I have to do this? But at the end of the graduate school, you really realize that it has given you something, a good momentum, which can give you a motion for maybe many, many years after that. Thank you very much.
Thank you. We don't have much time, so for the next few speakers, I'll request them to speak for 3-4 minutes. Prajwal, can I please call you?
Actually, I'm from the same batch as Sanjay, so in that sense, you should have got a more diverse. Yeah, well, so my name is Prajwal Shastri. I'm an astrophysicist. I got my PhD supervised by Vijay Kapahi, who many of you may not know because he passed on rather early, but he was in the what is now NCRA, the radio astrophysics group. I joined with Sanjay, that same batch. We were 10 of us in 1981. And I came very set on doing experimental nuclear physics in TIFR. I was inspired by my professor in IIT, Professor Prabhakar Kane, and that's what I wanted to do. But the thing was that when we formally joined, we were told, no, hold all your choices. We're going to organize visits by all of you to each of the groups, not just in Colaba, but all over the country, and then you come up with your decision. So actually, I was sitting with Sandeep over tea this morning, and I was shocked, absolutely shocked to hear that students are required to decide what they want to do for their PhD right when they join. I think that's a very retrograde step. I mean, this is a statement I can make with 100% confidence. I normally don't make my statements with 100% confidence, but this is one of them. Anyway, so we did that. We went to all the groups. It was extremely nice because, we all came from having done MSCs and sitting in classrooms and sort of, at least for me, I was just warming up to this idea that you could, somebody like me could actually discover new things. So this was a sort of a new idea because we had this idea that science was all done and our job was just to learn what is done and then teach it to others. And so this going to different groups included the Ooty radio telescope, the Bangalore Center, the TIFR Center, and TIFR was very broad-minded, so they allowed us to not just chat with people in the Bangalore Center, but also go to IISc. We had a lovely session with Professor Rajaraman, who was a professor in IISc at the time. We went to the Raman Institute, where Srinivasan gave us a spiel. For me, that changed my mind. It was the Ooty radio telescope, talking to seniors there, and Srinivasan changed my mind about doing nuclear physics, and I decided to do astrophysics instead because I realized that something which was my hobby could actually be my life's calling. One of the sweet memories I have of my time in Colaba was there was this person who had an office. He was an admin person who had an office on the 4th floor or something. No, not 4th floor. I don't know, 3rd floor. And he was sort of a rotund person. I can't remember his name. Parsi lineage. And you could... No. Putran is my lineage. So you could sort of sidle up to him and say, I really want to go to this piano concert in Homi Baba Auditorium, and he would give free tickets. So he had some free tickets in his back pocket. You can't remember his name? Oh, maybe Cooper. Okay. Yeah, so those were some of my sweetest memories, because then I would I didn't know whether this was legit or not. I didn't stay here long enough to discover if it was legit or not, so I would kind of secretly come into the Baba Auditorium. I would take the cough drops, because those days Western music concerts had a printed program, and they would come with cough drops so that you didn't cough during the concert. So, so I did those. Those were very sweet memories. And okay, I think I'll stop there.
Yeah, thank you. Very nice.
Hi, nice to be here. My name is Swaminathan. I was here during 1990 to 95, and I did my PhD with Professor Krishnamurthy, Professor Periswamy, and Professor Jayant Udgaonkar. So I'll just tell you a brief history of my entry and days of TIFR. Actually, I came to TIFR as a VSRP student in 1990, and I had finished my MSc in biotech from IIT Bombay. And molecular biology group those days used to invite students who have finished their MSc, unlike physics, which takes people in the first year MSc. So I'd already completed my MSc, and I was doing a VSRP program, and I was assigned to Professor Jayant Udgaonkar, and I really enjoyed the work which he was doing. And then I applied for PhD here to the molecular biology group, but unfortunately I was not selected. And I was on the waiting list, but I didn't get it. And then so I was a bit depressed, and then I was talking to one of the other people who were also a VSRP student, one girl called Shushmita Mukherjee. And she told me that, why don't you apply in chemical physics, because they do a lot of biological work. So that was like an eye-opener for him, for me. So it was just the last date. So I just put my application, but they said, you need reco letters. I said, it's difficult to get it in the last minute. So can you use the application reco letters which I made for molecular biology, can you transfer it for this chemical physics? They said, fine, we'll do that. So then I was happy I could give my application. Then I was called for the interview, but even that was a turbulent thing, because there were so many interviews to attend in India. I had an interview in CCMB Hyderabad, so I had to take a train and come back to Bombay, and I couldn't manage to come on that date of the interview. So I was actually, I asked my friend who was going to IIT Bombay to carry my suitcase, and I go to the TIFR directly from the station. And I came to TIFR around, say, 11 o'clock or 12 o'clock, past the time for the interview. And luckily, chemical physics, Nagesha was there in Marathe's room, and he allowed me to take the test late, alone in that room. And then I was waiting for the interview, which was already 6 p.m., around 6 or 7 p.m. that day. I was very tired also. Then I was almost a 1 hour interview for that PhD scholar position. And it was like a fantastic interview. They asked me everything I knew, and I didn't knew. I didn't do well. I thought maybe I'll not get it, but then they told me you've got it. So then I came to chemical physics. And then again, another turbulent period started. Because once I entered chemical physics, I was not ready. I was interested to do spectroscopy and those kind of work, because I have done biology, but then I was not interested to do pure biology work. And then the one thing which I didn't like that time is, wherever I was going after I was selected, "Aap kiske saath join karne wale ho? Aap kiske saath join karne wale ho?" So I said, what is this? I mean, give us some time to think. And one professor, he actually invited me to his room, and for 1 hour he was lecturing about his work. And I was anyway decided I'm not going to join him. So, but this is like, I couldn't, I said without any hard feelings, I'm sorry, I will not be able to take this. But he didn't seem to like it. And then there was a system of doing the projects and everything. So I did my first project with Professor Doraiswamy. I liked that project. I was introduced to the lasers and everything, so which was very new, which I'd never done before in IIT Bombay. Then in the second project was on NMR. I didn't learn much in that actually, and I totally kind of disliked that kind of project. Then it got so bad that finally I asked many people in the chemical physics group whether you'll take me. I asked Krishnamurti also. He said, no, it will not be possible. Probably, he said, I have to talk to some of the other members in the group, and probably it will not be possible. Then I was left with no choice. Then I found another person in solid state physics, Professor Jorori. He is doing biochemistry work. I said, fine, let us go to him. And then it was almost like I'm going to join him, right? But I don't know if by some quirk or something, he was going to United States for some sabbatical or something. So it got ditched completely. Then I was left with, then Professor Krishnamurti helped me, and he said, okay, you can come and join under me, I'll take you. So then he told me to take a project in molecular biology group. So then I was okay, so I'll join Professor Krishnamurti. And then he put me on to looking at membranes and those things. So I was okay, I was looking at water channels and membranes and whatnot. But then, the way luck turns, Professor Krishnamurti decided to collaborate with Professor Jayant Udgaonkar. And so whatever I wanted is happening. So I was again working on something on biology, but also using spectroscopy. So that was fantastic. So that's it's a great thing. And then about the graduate school. Yeah, and in the graduate school, I was literally crying in the graduate school. Because see, I was from biotechnology. I never had too much of mathematics. And the course by Marathi on mathematical methods for physics, all the physics guys are doing it. So I was totally out of the picture. And somehow, I don't know how I managed it.
You did fine.
Yeah. and yeah. So one thing I really enjoyed was the C programming course by R.K. Singh. And even in that course, I was crying because I was not able to pick it up. But then whatever I learned there, it was useful to write programs in this GK lab. Many of the programs I wrote for analyzing the decay, they are still being used today. Thank you.
Thank you. Ravi has been telling me you have to shut this down. I'll call Kailash. This will be the last one. And of course, I'll have the last words. But
Yeah, good morning. I'm Kailash Rustagi, joined here in '65 with Professor Jha and finished in 1970. But when I came back after my postdoctoral stunts and joined BRC, I actually continued to work to keep my contact with TIFR. It was convenient for two reasons. One was there were a lot of people here who were very useful for whatever I wanted to do. And the second was I used to live close to this place, so one day less of commuting. So I made a deal with Dr. Bhavalkar that one day a week I will not go to BRC and go to TIFR instead. So generally Wednesdays I chose. It was actually in retrospect, it was taken, the decision was taken somewhat spontaneously, but in retrospect it was very useful in a very different way. BRC being a government organization and TIFR not being a very government organization are different cultures. And it somehow, over lunch meetings, over talking to Mustansir or Deepak or Jhaji or anybody, it sort of kept my balance. We had great communication. There was a time when I did some paper which was a quickie. It was a problem which came out of some experiment that we were doing, and I made a very quick theory. I was not sure whether to send it for publication or not. So I went to Jhaji's room to show him the thing. It was handwritten manuscript. And he was not there in the office. So I left it in the office with a comment saying that, can you please look at it? I'm not sure whether to send it for publication or not. And Then I went to library, did whatever else I wanted to do. And in the evening I went again. He was still not there, but he had read the paper and he had his comments on that. And we did send it and it got published immediately. So we had another interaction with him when he edited that book, which is an excellent book, I think not read by many people, not sold that much as it should have sold. It had a very broad spectrum sort of treatise on optoelectronics as of that date. I've had a lot of contacts with, I said Mustansir, Deepak, these are kind of resource people. And in BRC, when I had 2 theory students, I realized that the graduate school was important. And I again used my resources, asked Mustansir if they can attend his course. And they did. And it actually built a bridge for them. So that is why I feel that some amount of informality actually goes a long way to manage things. And I would wish that some of that returns to TIFR.
Thank you, Kailash. Thanks for the time. So, on popular demand, we'll have 2 or 3 more. Jyotsna, but please, 3 minutes.
I'll take only a few minutes. Yeah, I'm Jyotsna. I'm originally from Hyderabad. I did my master's in University of Hyderabad. And since there was some query about theory only, has been given the preference. So when I came to TIFR, I came with the mind that I should do theory, but thanks to outreach activities and also talk by Professor Mandal, I decided to do experimental high energy physics. So I feel really proud that I chose that path because I was waitlisted in CTS in ISC. Now after getting the training from here, as well as my postdoctoral research, now I have started a group, experimental group in CTS. So, so that's I usually say that so if people do not get a chance to do PhD there, so they might probably start a group which they got trained elsewhere. So that's what I tell to my students. And what I think is I got an opportunity to get exposure to the experimental field for the first time because in the university, there are mostly the training done in the theory background. Okay, so that's I would like to add. And only a couple of things probably I just want to add to the kind of feedback which I couldn't give yesterday was probably it would be a good idea to have a database of all the TIFR alumni over the last 50 years. And usually at CERN or CMS experiment, what we do is we invite people who are in non-academia to come and give a workshop so that the students here who do not want to pursue academia but want to go to other fields, they get an exposure. So we encourage that a lot at CERN. So it would be good to have. And for the database part, whatever best I can contribute, I'll be able to contribute in nearby years where I was the PhD student here. Thank you.
Thank you. No, thank you. Yeah. Can I call on Ajay Thakur from IIT Patna? Thank you.
I think we are already running short of time, so I will keep it brief to two points. One is regarding this graduate coursework, so one cannot overstate its importance. Particularly for our batch, which was I stayed here during 2000, 2006. So for us, we had graduate school courses by people like Professors Sumit Das, Professor Mustansir Burma, Professor Deepak Dhar, Professor T.P. Singh, Professor Rajiv Bhalirao. And I must say that despite having done MSc from IIT Bombay, where we had a fairly rigorous course, I would say the approach taken by all these teachers was very fresh for us. So that is one point which has to be ensured while planning courses for graduate students, because you are trying to take them through a journey of perspective of different subjects. And like, it cannot be a routine MSc course. That's one point. And at a new institute like IIT, our grad school is also 10 years old now. It started in 2000, the grad school started in 2009 at IIT Patna. And for the last 2.5 years, I'm taking care of the graduate program in physics department. So like whatever was learned here, like at least to teach students at various levels from UG, MSc, MTech, PhD, and to train them to break glass ceiling, you have to at least touch the glass ceiling. So this grad school really teaches that. The other point is more focused on the research work. So here I would like to point out that the initial projects, one done in the theory group with Professor Nandini Trivedi, and the other one with Professor B.M. Arora, that really gave me initial insights of how to do research. And one of the interesting instances was when I was sitting with Professor B.M. Arora under a table at 2 a.m. in the morning for almost, I think, 1.5 hours, and we were discussing, so the project was related to semiconductor optical amplifiers and how to couple fibers together. And now coming to this PhD program, like I did my thesis with Professor Grover and Professor Ramakrishnan, and this was a very interesting combination for me. Like while Professor Grover ensured that, like I did a reading course with him. So he was very meticulous, at least for like 4.5 months. And there were 2 young graduate students in his group at that time, me and Deepshika, who is now at ISR Trivandrum. So he ensured that for those 4 months, we are like really ready with the perspective or the background of the area in which we are going to take up the work. And then we were left to find out what is the open problem. So like there was reasonable hand-holding, but enough freedom to really ensure that the problem identification is learned. And on the other hand, Ramki was a hands-on person. So first thing he did was, okay, you take, my first day in lab was, he gave a, I will take 1 more minute. He gave a temperature controller and said that you have to repair it. That's your task. And like he assigned it at 8 a.m. or 8:30 a.m. He was an early person in the lab. And by 12, he came back when I was kind of putting that temperature controller back. So he asked me, what are you doing? My first statement with him was, I'm screwing it up. Right? Actually, I was putting back the screw. So he said, oh, is it not working? No, so now it is working. So there were some network cards and there were some issues, and then we were able to figure that out. So like these, like overall, this grad school plus this training that I obtained here, I must say that a good graduate school program can really make you fearless, take up new domains, completely uncharted domains on your own, and that is what we are attempting there at IIT Patna. Thank you.
Thank you very much. Thanks. So we are coming to an end. I also have to say I'm very grateful to TIFR. I think all of us are. TIFR made us what we are, give us confidence, go to any new area and we know how to deal with it. And I think physics also has something to do with, once you've done experimental physics, you're willing to take on anything, right? And I never felt looked down upon for doing experimental physics. When I joined the IIT system, where I have been now for 30+ years, a lot of experimentalists turned into, modeling or theory, because it was really tough to do experimental work now. That changed, and we have really very good equipment and support now. And so in future, we hope. So I want to say that one of my first PhD students' son just joined TIFR this year. He wanted to do physics, and he asked me, these are my options. I said, go to TIFR. That's it. So
And finally, though Sanjay talked about many things, he has escaped now, we used to have wonderful music sessions in the hostel. Sanjay Jain, Bajji, and Paritosh, who has also escaped, he said that we'll end the session with one of those songs, but clearly they were not serious about it, so they're all gone. So thank you very much for organizing this, Ravi, Vandana, and Snehal, Kishorji, and till the next time, whenever that happens, hopefully not in 50 years. Thank you.
Thank you, Inakshi. I know it's very difficult to compress decades into minutes. And I can't resist saying that the problem is not with theorists or experimentalists. The problem is with theoretical experimentalists and experimental theoreticians, right? So we are what we are. TIFR has made us, most of us, and we are proud of what we are. So now it's been a great event, but we have to bring it to a real nice conclusion. And so I invite first Amol, to come on stage and say a few words.
Okay, so it's my job to thank everybody who has been here and has been behind the scene to make this event the way the event it was. I think I should first start by thanking Arun Grover, who was the one who initiated this, sort of pushed me and some people here, and I think perhaps also managed to convince Sandeep to really go ahead with this event. And the next thanks would go to the Alumni Association, because of course we have, as University Cell has contacts only with the students in the system, but Alumni Association keeps touch with everybody who has been here for the last 50 years. I understand that they have also, well, I understand that they have now taken up some campaign of starting to increase the reach of alumni, getting the database in order, and maybe people will be told more about, you'll be more informed about what's happening in TIFR. Then of course, Mr. Amit Roy, who once he took it over, I think he has been involved in every aspect of organization of this. And of course, so has Vandana Nanal, who, if you realize, I think never came on stage during this. But she was sitting in the third row here, and the reason is because whenever some crisis situation came, she would run back, and so she has handled I don't know, all the logistics. She has handled the press. The press came at random times. She came and gave interviews. She was the one who would tell people, no, now you should stop this in 5 minutes because something is going to happen. And so most of the things that have happened here have happened because Vandana was sitting in the third row or fourth row on this side and was managing things from. One of the important things that happened as a result of this is we did try to come up with a history of graduate school. This is the booklet that you all have seen. I should take names of people who actually contributed to this because they are in the booklet. However, they may be missed, but I think I should mention them specially. So for physics, the inputs were given by Arun Grover, Professor Jha, Sunil Mukhi, Professor Mukunda, T. Padmanabhan, Rajaji, Ramki, and Professor Probir Roy. For mathematics, they were given mainly by Professor Raghunathan and Professor Dani. For chemistry, the compilation and report was given by GK, who also was one of the Dean Graduate Studies of the university earlier. For biology, we obtained them from Gaiti Hassan, M.K. Matthew, Shobhana Sharma, and Mukund Thatte. For computer science, we got them from Professor Mathai Joseph, Sandeep Juneja, and Paritosh Pandya. For radioastrophysics, we got them from Jairam Chengalur and Nisim Kanekar. And for Homeopathy Center for Science Education, we got them from Arvind Kumar. So I would like to thank all of them for helping us in compiling this. As I said earlier, there have been perhaps some mistake in this, and mistakes are all mine. And I would actually like to acknowledge something which was brought to my notice. If you had seen outside the notice board, you would see that the notice for TIFR having been made deemed university actually came in May of 2002, and at that time Professor Jha was the director. By mistake, the booklet actually names Professor Bhattacharya. I think I would like to publicly acknowledge that this was a mistake in the booklet, and I think, of course, everyone knows this, but I think it's good to be clear about this. While trying to organize this event, we had a lot of help from the archives, and we actually went through some very entertaining and educative material from the past. You will see them, some of it on the notice board outside. For example, you would be able to see the mark sheets of some of our eminent people who are sitting in the front row. Actually, the two who are sitting here in the front row. So your marks are no longer secret, but the mark list was for meritorious student who went through the TIFR, through the atomic energy, the training program. You'll also find names of some of the people who were research scholars and visiting fellows in the early times of 60s and 70s, and some of you will find your names there. We found a lot of material. It was very difficult to put everything on board, so we have just put some samples. We managed to find the first degree certificate given by TIFR, and yesterday I also met the student whose certificate it was Jayan's student, and is she here today? Perhaps she is not here today. Huh? Sridevi, yeah. So K. Sridevi, you can see that certificate here. So some of these things that we never think we would find were actually found by the archives, and I think we are very grateful to the archives for having made this happen. I'll thank everybody who contributed to the panel session yesterday, and either from the panel or from the audience. Your suggestions, your feedback has been taken into account. Has been of course recorded. We also had a couple of people who were taking notes during that, and we will take care of this. You also were perhaps sent a Google form to fill about your feedback. What we will do is, at least since you are here, it shows that you are really interested. So we will send you the link to the Google form again, so that if you have missed sending your feedback there, you could still give your feedback. We'll keep that open for about a week or so you can perhaps know now or after going back to your homes, you would be able to give that feedback, and we will make sure that we take that into account. So right now, that's all I have to say. I think I would invite Professor Amit Roy for the rest of the vote of thanks session. Amit, please.
Well, as for all good things must come to an end, and I think this gathering is absolutely a fantastic gathering. Marvelous things, getting to meet so many people from the old times, from my friends and some teachers and colleagues and students as well. It was a fantastic experience. And then when we started, and in fact, the starting as we have all attributed to Arun Grover, and it so happened that he called me up, he gave me a call one day in sometime in, I think probably March or April or so of this year. And then he said, we are trying to organize something like this, 50 years. I'm in Bombay now, right now. So I said, we want to discuss these things. I said, the very next day I happened to be coming to Bombay for some meeting. So I said, yeah, I'm coming in the morning. My meeting will be over by lunch. So after lunch, I can come over if you are around still. He said, yeah, I'll be there and I'll be in Sandeep's room. So why don't you come over? So next day I was there. And then we sitting in Sandeep's room, and then we got Amol was there, and Ravi was there, and then I don't remember who else was there in that particular meeting, and they discussed this, and we thought about the idea. Arun, as usual, is very, very meticulous, and he comes out with a lot of enthusiasm on anything that he thinks about, and he always bubbles out his ideas and keeps on throwing so many ideas around. So he said that, and then he said, all of them then looked at me and said, why don't, since you are, you almost predate that, ours was the first batch, actually we call it our zero batch, because we were the guinea pigs for the graduate school. Everything was tried on us. We had to take in the first year 9 courses, all compulsory, including molecular biology. So in fact, maybe I should recount that particular one experience on molecular biology to show that how serious Chanchal Majumdar was, who was taking care of that because Professor Jha was not there in that particular year. He was outside. So he took over from 69 again when he came back. So 68, then when first day the molecular biology course was announced, we didn't go to the class because we thought this one must be for the molecular biology students. So there were 5 or 6 molecular biology students even in that year itself for PhD course, PhD students were taken. So this then on the lunchtime in the West Canteen, I was having lunch with my friends, and suddenly I got a blow on my back, and I looked back and see Chanchal Majumdar sitting there, and he said, "Where are you at 10 o'clock in the morning?" So I said, I was in my lab and doing something. He said, no, you guys must have been sleeping in the hostel because you didn't come to the class. I said, which class? He said, molecular biology class. So I said, but why should we do molecular biology? I want to do nuclear physics. He says, no, this is a course specially designed for physics students and it's compulsory for all of you. So we had to go. And then he would also come and join in the class, and he would be sitting there in the AG80 so that no one could escape as well. So this was the kind of grind we had to go through, but it was absolutely great because that made us, as many of my colleagues and others have pointed out, that grinding at that time that we went through, and it was all serious academic grinding and for our own good, and that made us what we are. And as everybody said, that gave us the self-reliance, confidence that we can do anything that you want to do. And one incident, in fact, I've noted down in the book, I've given in my recounting in the brochure also. That was also very revealing. In fact, I haven't given the name of the person. See, one day I was having breakfast in the West Canteen, and then and Vijay Kapahi was my senior. He came and sat in front of me, and he kept on asking. He just asked casually, "What are you doing?" I thought it was a casual talk, so I said nothing much interesting. He became very serious and said, "What the hell are you doing then? If it's not interesting, why are you doing it? Who asked you to do that? This is not the place to be doing uninteresting things." And that actually immediately struck me so much that from that time I decided, I told myself, I'm not going to do anything that I'm not interested in. And I followed that through. So this is, that showed me the spirit of TIFR. That you have to do things, you have to be passionate, involved in everything. So this is what I think this is what we thought when we had the planning for this GS50, that this is one thing we'd like to share. And probably with the present students also, they will be, they'll see that how things have come up in this institution and what has made it unique. So this is showcasing that. And I think you have succeeded in that direction. And thank you very much thank you all very much on that direction for making it a success in that. And we have got in the panel discussion, all the panelists have given their various points, and I'm sure some of them, all those that can be addressed will be addressed, and in the spirit of TIFR, because the feedback system, or any system which runs well, the feedback system has to work very well. If the feedback is good, the system is stable and runs well. So I think that has been the case in TIFR, and I am sure that this tradition will continue. So since Amol has already taken care of most of the acknowledging most of the contributors, I will like to. I'd like to acknowledge some of the few others who have made this possible. Again, I would like to thank the Tata Trusts and Professor Chitre especially for making this event happen, because without that support, it would have been difficult to organize. We would have still probably managed to, but it would be a little tougher it made us life easier with their help. And the alumni who have donated generously, and now I think for the Alumni Association, the task is cut that we have to think of some programs and then ask the people's help. And I'm sure we can carry on the events. More events can be done in that way and be in contact. And I think this is a resource that we have, the alumni, various places. Certainly we can contribute in many ways. I'd like to also thank the three people. I'd like to now take the names, and I'd like to acknowledge their contribution. One is Snehal Samant, who has been very active in this thing, taking care of all the secretarial work. Let's give a big hand. Then Kishore Menon, he is one of the liaison, and contacting people in all the various work, which he still continues. He was doing the public relations earlier. He still does, even after leaving TIFR, he still does public relations for TIFR. And now I'd like to call Vandana on the stage. Because, see, I was in the convener only from a remote. I was only doing the remote control. So all the actual work was being done by Vandana here. And so you give her a big hand.
Please move to the center.
Yeah.
Say something in
Yeah.
No, thank you very much. All the work, actually, Amit is giving me undue credit, I think, because it was wonderful working in the team. Of course, the whole organizing committee also helped us, but particularly working with Amit was, because he took care of all the logistics and all the problems you call him, he will send the mails and sort it out. So, and another major thing is organizing anything in TIFR is always easy because everybody and on all corners you get the support. So, thank you very much. It was really a fun event.
Stay here. So please move to the center. So this is unscheduled, spontaneous. Amit said all good things have an end. But I would like to think all ends have a great beginning, right? So now I'd like to call upon the people who are tasked with moving the future. So can you move to the center? So in the spirit of the great events that used to happen in this auditorium, I would like to invite all the actors back again. So Amol, Snehal, Kishore, please come on stage. Arun, Sandeep, back on stage. So that we can take a bow and thank everyone formally and say that, well, each of us says that the other people are responsible for the future. So,
some of the people really responsible for the real future are sitting at the back there, the current graduate students. I still see some of them in the audience.
They can join too. Where's Sudipto here for the next 1 year?
I really shouldn't be here.
So, thank you very much. Pleasure. So go home safe and come back as often as you can.
But they can go home after lunch.
After lunch.
After lunch.
There is lunch.